Welcome! In this short video, we will see how Akamas can optimize applications leveraging serverless computing resources such as AWS Lambda. With AWS Lambda, finding the right balance between memory, execution time, and cost can be quite tricky. Let's see how Akamas can help. In this optimization study, we consider a simple application based on two functions. A simple forwarder function, which only acts as a dispatcher, and a backend function, which performs the actual computation. The optimization goal is to minimize the overall response time and cost. The goal function is defined in terms of the duration of the forwarder function and the cost for both the backend and the forwarder functions. Before analyzing the result of this study, let's go to the optimization pack for AWS. In Akamas, an optimization pack for a specific technology provides all the parameters that can be tuned by Akamas optimization engine and all the metrics that can be used to define the optimization goal. For AWS Lambda, the relevant parameters are the memory size, which also drives the virtual CPU assigned, and provisioned and reserved concurrency. The key metrics are the duration of the function and, of course, the cost of the function, which is a calculated metric. Let's now go back to the optimization study. The tuning parameters for this optimization study are the memory size for both the backend and the forwarded functions. As we can see, the baseline configuration for both functions assigns 256 megabytes of memory each. This is just about the minimum recommended value. Let's now analyze the results of the experiment executed by Akamas and the best configuration. In this chart, each dot corresponds to an experiment that is automatically executed for each configuration identified by Akamas AI as promising based on the results of the previous experiments. The first dot in the chart corresponds to the baseline configuration. At experiment number 14, after about 1 hour, Akamas automatically identified a much better configuration. Let's now compare this optimal configuration with respect to the baseline. Let's go back to the summary. As it can be expected, the optimal configuration allocates much more memory to the backend function, which is doing the real computation, and less to the front-end function, which is just dispatching calls. It's worth mentioning that Akamas identified this configuration thanks to its reinforcement learning, without relying on any modeling or any knowledge of the application architecture or logic. Akamas does not simply provide the optimal configuration, but also multiple configurations. This rudder chart shows how those configurations compare with respect to the metrics we included in the goal, that is, the duration and the cost of the two functions. To make things even more clear, let's highlight just those configurations that improve on all the metrics. Thanks to Akamas, it's possible to understand potential trade-offs between competing goals and support decisions on how to best reconfigure the system under analysis. This concludes our short video about how Akamas can optimize both performance and cost of applications leveraging serverless computing resources. The system under analysis in this video was quite simple, but Akamas can manage much more complex applications based on any number of Lambda functions or including other components such as JVM, runtime, databases, and more. Thanks again for your interest.